Today's lesson is on estimating square roots. Perfect squares are numbers whose square roots are whole numbers. Examples of some perfect squares would be taking a number and multiplying it by itself, just like the dimensions of a square are the same number. So 2 times 2 is 4. 4 is a perfect square. 5 times 5, 25. 25's a perfect square. Let's go with 8 times 8. 64 would be another perfect square. Non-perfect squares. Non-perfect squares are numbers whose square roots are not whole numbers. Examples of non-perfect squares would be 2. You cannot multiply the same whole number by itself to get 2. The closest would be 1 by 2. The number 7. 7 is a non-perfect square because you can't multiply the same whole number by itself to get 7. How about 63? 63 is a non-perfect square because no whole number can be multiplied by itself to get 63. We can use our knowledge of perfect squares to estimate the value of non-perfect squares. Today we'll practice estimating square roots in each of the following questions. Number 1. Estimate the value of the square root of 50. The square root of 50 is not a perfect square, but I can get close to that. 49 I know is a perfect square. 49's square root would be the dimension of 7. 7 times 7 is 49. After 7, the next number or whole number is 8, and 8 times 8 is 64. So I know that 50 would lie somewhere between the whole number 7 and the whole number 8. It says determine which perfect square it's closest to. Well, I know that 50 is only 1 away from 49, and I know that it is 14 away. 50 and 14 give me the next perfect square, which is 64. Since 50 is closer to 49, the square root of 50 will be closer to 7 than to 8, so it should be just a little bit over 7. So if I was going to estimate, I think a good estimate without a calculator would be about approximately 7.1. We're going to continue this thinking. We're going to try to estimate the value of the square root of 22. I know that 22 is not a perfect square, but I know that 5 times 5 is 25, but that's a little bit too high. I'm going to write that down. I know that 1 lower than 5 is 4, and 4 times 4 is 16. So I know that the square root of 22 would be between the whole numbers 4 and 5. So the square root of 22 being between the whole numbers 4 and 5, but it's only 3 away from 5, so I would say it's closer to 5. So if I was going to estimate being close to 5, but not exactly, I would say maybe 4.7 or 4.8 if I had to not use a calculator. Number 3, estimate the value of the square root of 103. I know 100 is a perfect square, and I know that side length would be 10, so the square root of 100 is 10. I know after 10 comes 11, and 11 times 11 is 121, so 121 is a perfect square. I know that 103 is just a little more than 10, so it would be between the whole numbers 10 and 11, but closer to 10. If I was going to estimate this one, I'd say again a little over 10, so maybe 10.1 or 10.2 would probably be a good guess. Moving on to the back side for page 2. Here we've got some questions, multiple choice questions to begin. It says, which of the following square roots is best represented by point A? So if I'm talking about the whole number 3, then I know its perfect square would be 3 times 3, or 9. The square root of 9 would give me that dimension of 3. Therefore, this one would be 4 times 4, which is 16. So I know that it's going to be more than 3, or more than square root of 9, but less than 16. So I think the best estimate would be the square root of 15. The next one. Which of the following would be the best estimate for 198? Well, I know that 14 times 14 would be 16, carry the 1, 5, 0, 4, and 1. So that gives me 196. So I know that the square root of 196 is exactly 14, and since this is just a little more than that, I think the best answer would be 14.1. Next question. Between which two integers, remember integers are whole numbers and their opposites, would the following lie? The square root of 90. Well, I know that 9 times 9 is 81, and so that would be the whole number 9. And I know after that is 10 times 10, which is the square root of 100. So I know that 90 would fall between 9 and 10. 175. I know that 14 times 14 was 196. I'm going to check 13 times 13. 9, carry the 1, 4, 0, 3, 1, 9, check my math here, 4, 0, 3. So 179, that's not right. 3 times 3 is 9. I don't know why I carried a 1. This would be 6. 169, that sounds better. So I know 13 times 13 is 169. And I know 14 times 14 is 196. So the square root of 175 would fall between 13 and 14. Last one in between. Which two integers, which two whole numbers or their opposites? And I notice there's a negative out front. I'm going to ignore that for now, but I know it's going to be between two negative integer numbers. If I think about the square root of 12, I know that 3 times 3 is 9. So the perfect square, 9, square roots to 3. I know that 4 times 4 is 16. So the square root of 12 would be a little less than 4. But because of this negative in front, you can think of it like the opposite of. So the opposite of 3 is negative 3, and the opposite of 4 is negative 4. Therefore, the square root of negative 12 would fall between negative 3 and negative 4. Word problem. Rebecca bought a square table for her kitchen. The area of the table surface is 65 square feet, or feet squared. What is the approximate length of one side of the table? I like to draw pictures. I'm going to draw a picture of her square table, and I'm going to put down what I know. I know that it's 65 square feet inside. That would be 65 tiles, but that wouldn't make a perfect square. I know that 8 times 8 is 64. Therefore, 65 would be very close. So I know that these sides are going to be a little bit more than 8. 8 times 8 would give me 64. So if I was going to approximate, I would say about 8.1 feet. 8.1 times 8.1 would get me close to 65 square feet. Last question. Create and label a point on the number line below to represent an estimate of the following square roots. I'm going to start by putting the perfect squares above the whole number square roots. I know this is 1 times 1, so its square root would be 1. The perfect square would be 1. I know 2 times 2 is 4, so its square root of 4 would be the whole number 2. Keeping this going, I get 9, 16, 25, 36. The 7th perfect square is 7 times 7, which is 49, 64, 81, 100, and 121. These would be the first 11 perfect squares, which would square root to our whole numbers. This allows me to estimate much more quickly. The square root of 5, point A, is going to be a little past 2. The square root of 88, I know, is going to be between 81 and 100. If I think about that, the halfway point would be about 90, and so that's going to be really close to the halfway, so that's going to be point B. Point C, I guess I should put a point there. Point C is square root of 17, so that's got to be a little past 4. So I'm going to call that point C. Make sure I label it. Change this to a point A, sorry. Point D, 118. I know that's going to be a little less than 81, so I'm going to put my point, getting better at this, and call this point D. And the square root of 56 has to be between 49 and 64. 50 and 64 is 14, 7, so that's going to be pretty darn close to the exact middle. So I'm going to call, oh, I just totally did that in the wrong place. 49 and 64 is going to be about, and so we're going to call that point E, and we're just going to scribble this out because it's okay to make mistakes in math. All right, so I have A, a little past 2, C, a little past 4, E, almost right in between 7 and 8. I have B right in between 9 and 10, and I have D between 10 and 11, but closer to 11. So if I was going to summarize today's lesson, we worked on estimating square roots that were not perfect squares by using those perfect squares. So I am working on using perfect squares to estimate non-perfect squares. And the square